So what we're going to be doing today is we're going to be running through a bit of a hands-on demonstration of what the Nexus platform can do for yourself and give a quick illustration on what the potential things that can go wrong when managing a complex software supply chain. So to everybody just joining, I run the pre-sales team here at Sonatype, and as a part of that commitment, I get to see a ton of our customers, a ton of different types of companies across the world deal with the problems that arise from the increasing complexity of software supply chain. So I prepared a little demonstration for everybody today that will showcase how you too can start taking a gander into the mysteries of the software supply chain, and show an interactive demo of how you can see this working for yourself as well. So the fact of the matter is, today, every single company is a software company, whether or not we like it. And over the last 10 years, our industry has moved on from trying to create the best piece of software, the most handcrafted piece of software, into trying to find competitive advantages from being able to release faster than their competitors. Today's winners always come out on top by being able to release faster than their competitors. And what that has resulted in is an adoption of trying to cut corners, trying to find efficiencies, and obviously not to do every project from scratch. Over the last 15, 20 years that we've been in this industry, we've seen a rapid push towards modularization of software and a rapid increase in our reusability of components. The pipe dream from 10 years ago about portable, modularized, and component-based software has arrived today, and the best companies out of all of the companies out there, the absolute DevOps elite companies that release faster, release more often than daily, release quicker than their competitors, and get their value in front of customers. Now, if we look at the change that has done to the software industry, what that means is that the actual very shape of software engineering itself has changed over the past 10 years. Applications are no longer written from scratch. In fact, as we well know, most pieces of software today, when we look at enterprise applications, are actually assembled mostly from third-party components such as open source frameworks, libraries, off-the-shelf convenience libraries, etc. as well. In fact, when we look at a standard piece of open source, the standard piece of enterprise software, what we can see is typically about 80 to 90% of that software is actually comprised of third-party or open source components, and only really about 10 to 20% has been written in-house or is completely proprietary. What that means, that has given us a lot of benefits. Using open source is a great boon for the industry, because it allows us to conform to those intense pressures of being able to ship software faster to our customers. It allows us not to get stuck on reinventing the wheel, not allows us to get stuck on reintroducing the basics or inventing things that we don't need to invent, because there are much more better comprised pieces of open source out there. What that also means is that we as an industry are shipping software faster than we ever are. In fact, when we looked at the DevSecOps community survey that we conducted this year, we found out that almost half of the respondents were already doing weekly deploys, if not more. What that has also meant on the supply chain side is the supply of open source itself has grown exponentially year over year. We here at Sonatype, as custodians of the central repository, which is the go-to destination for any Java build that is out there, have been witnessing this firsthand over the past 10 years of operation. We've seen a steady growth pace of about 50–60% of the Maven central repository in terms of download volumes, and we're observing the exact similar trends across all of the other major ecosystems, across all of the other major open source providers. When we take these together, the supply of open source is at an all-time record high. As developers, we have more choice than ever to select components to build our applications from. Unfortunately, as we all know, that does come with downsides. With that increased complexity of open source and supply that is out there, unfortunately, not all of it is created equal. Even the best open source doesn't age like fine wine. Unfortunately, it doesn't get better with age. Sooner or later, especially when we're talking about higher profile or commonly used pieces of code, something might go wrong. Now, that doesn't necessarily mean a security vulnerability. It could also mean licensing changes or other quality-related issues, like a release just growing stale. We here say open source, ages more like milk. For a long time, it's good. It's extremely useful, but when it does go off, you want to be replacing it fairly quickly. The complexity of this all is actually best illustrated when we look at an ecosystem as a whole. This is actually a complete visualization of every component that was present in the central repository about 5 years ago now. So today, the size of this visualization has grown way beyond the boundaries of my screen, but I find it as a very good illustration. Each of these white dots here on the zoomed in bit actually represent singular pieces of open source. And the orange lines between them represent the dependencies of one open source to another. Just like we as developers have a great idea of using open source as a part of our software, so do the developers of those pieces of open source. What that means is that one open source component can rely on another, and that transitive chain can grow to be fairly large. A typical Java piece of software has about 106 open source components in there. And when we look at modern software applications that are built like microservices that have multi-language bases, we can easily start arriving at numbers of 200 or 300 modules per little microservice. The most modern addition to all of this is, of course, containerization, which adds another level of complexity in managing these sorts of components. What that has led us as an industry is at a completely new pressure of being able to conform and manage this volume of components that we're observing across all of our applications. Another interesting aspect that this brings to the table is Gartner actually a couple of years ago released a blog post where they said that by the end of 2020, by the end of next year, they believe that 99% of all the vulnerabilities that will be exploited of known vulnerabilities will continue to be the ones already known by security and IT professionals. This added complexity means that the silent killer isn't necessarily the zero-day attack or the new security vulnerability that happens today or tomorrow. It is the risk that's been sat in your application, in your unmanaged or unforeseen software supply chain for a long time that might not have been seen for a while and might end up us having issues that we hadn't foreseen before. So let's think about how you would produce software in a modern way today, and illustrate this through a demonstration. So typically, when we start a software production project, what we end up seeing is something like this. We'll start off with a template. Nobody wants to start from scratch, and there's no good reason for you to start a project entirely greenfield unless we're inventing completely new technology. Most of our project needs can be fulfilled by selecting a framework that already exists out there, that is relatively well supported, that has a great community around it. A good example of such a project is Apache Struts, which is one of the most used frameworks in the Java world. Now, often, especially when I was a developer, what ends up happening is we'll learn the framework as we go along. We'll start with a sample project, expand upon it, start filling it in with our functionality, and then deviate from the known path as we go along. As we get more proficient, we can take more liberties with the framework, but initially we want to be starting with a known baseline that allows us to work. And of course, any stable hold of modern software development relies on our ability to containerize it. Containers are a wonderful thing. They allow us to take our software, run it exactly as it would run in production in our local environments. So if we take this logic to its next level, what we can just simply do is start off with a template piece of software, using a commonly known framework, and run it through using a container, and be able to run it almost immediately. So herein follows our demonstration. Do try this at home, kids. This is something that anyone can go ahead and attempt to run at their own pace. We published a community repository called struts2rc under our Sonatype Nexus community registry on GitHub. The only thing you'll need is Docker to be able to be ready to go. If you have Jenkins, we also have work there for you. Now, so here's something that I prepared earlier. So we're here at our Nexus community repository and at our Struts2rc project. And the anatomy of this project is fairly simple. It just clones the web REST API example from the original Apache 2 projects from Struts. That is compounded by a Maven project that takes that source code and builds it into a runnable web application. A fairly simple pipeline. We also have a Docker file present here that takes a standard Tomcat container, Tomcat being used to run the server, put some very important environmental variables into this mix, runs the build, and waits for it to run in our local environment. Finally, it runs it on port 8080. So if you want to do this, feel free to fork this for yourself. Feel free to clone it onto your machine. And when you do, you end up in a folder with something like this. Now, building this software is fairly simple. We've included a little Maven executable that you can just run. You should not have any other requirements here. Running this takes the source code. We're free to edit it. You're free to edit it, but we take the source code, we run it in our local environment, and we get a successful build. Once we've done that, as a developer, probably the next step that I would like to do is make sure that this system runs. So we can just use the Docker file that I've added earlier. We can tag it with something interesting. I'm just going to call mine webinar. And I'm going to say, let's run this at this root. Now, I've of course pulled all of the containers already. If you're doing this for the first time, you're probably going to be experiencing a little bit more of a wait than I have here. But as you can just see, we've added a Tomcat container. We've taken our web application, put it into the container, and exposed it on port 8080. So if I run it, I can just simply run docker run -d. We want to run it as a daemon. And what I'm going to do is expose port 8090 instead of 8080, just to make my own life a little bit easier. And I'm going to call this web just for my convenience. Sorry, webinar. Here we go. Now, as you can see, this is live. Now that it runs, let's just make sure that we have our application being executed here. We can see that if I go to localhost 8090, we can see here that our application is coming up, and it runs the struts template application. Now, this is a sample web inventory application, so it allows us to create new orders. For example, I could ask my colleague Moose to order 15 or 14 of anything that we would like to order. We can view these orders, we can edit it. It's a completely functional web application. So potentially, the next step that I would like to do here is perhaps take this into Jenkins. Now, we've included a Jenkins file here that takes the project, runs it in Jenkins using the Jenkins pipelines, and then runs our Nexus IQ policy evaluation. As you can see, I'm running this application, and already I'm running on full cylinders. So if I onboard this application, the only thing I have to do is just create a Jenkins pipeline job, add our build into this pipeline job, go here, point this to my project. Since I'm running it locally, in my machine, the only thing I have to do is just take my local repository directory, put it in here, and say, we can now run the job. And just to make it a little bit prettier, I'm going to be changing the blue ocean so we can see the build starting. So the structure of this build is fairly simple. We run the Maven build locally, and as we can see, the build runs successfully. And once that is complete, our Nexus lifecycle policy evaluation begins. The way this works is it actually audits the files that we've just built based on this Jenkins build job, and we go through the application line by line, identifying every single piece of open source, Java, JavaScript, .NET, Python, Ruby, whatever we might have bundled in here. What we actually do is we take its structure as well and identify what is actually going on within those components. As we can see, once that's done, we run a quick evaluation based on our open source policies to come up with a view whether or not this was compliant. And as we can see, it was not. So what went wrong here? Well, I can see that we were failing the build because of a few known security violations. We can see here that we've failed the build because of some security critical issues that we have with this particular application. Now, I can access this myself in my local Nexus IQ server. This actually generates, every time I run this build, it generates a bill of materials report that shows me exactly when the build was run and what was contained in there. And as we can see, we actually have a few critical security vulnerabilities. We can see that the struts2 version that I've chosen for this actually contains a vulnerability where we can run a remote code execution flaw, a remote code execution vulnerability against this container. That sounds pretty scary, but how bad could it be? Well, what I've done here within my registry is I've actually added a script that allows you to test this out for yourself. It's just a Python script that we've borrowed from a existing Metasploit module. But what this does is it can actually work against our sample application. So what you can do here is go to a struts page, just copy a action page URL, and we can go here to run our little script. It's fairly simple. It's just a Python command. You need Python 2 to be able to do this. We point it to this thing, and we give it a command. So the typical command might be pwd. As you can see, I immediately get a response. It says USL local Tomcat. That means that we are running inside of the container. Now, from here, we could do several things. As a exploiter of this sort of vulnerability, I could be doing several different types of activities. But probably the most interesting thing I could do is just see who am I running as. Actually, this user is running as root. Well, that's interesting. That means I could easily be doing things like writing new files or adding new content inside of the system, which means I have full control over the system. Luckily, our Nexus lifecycle scan has coded in our builds. So what would I be able to do in order to prevent this from happening? Well, the good news is we also have plugins across the entire SDLC that allows you to see throughout wherever you're working as a developer what is actually happening in your software. I would, as a developer, probably work in my IDE. So we can use our Nexus Lifecycle plugin for any of the most popular IDEs that are out there, IntelliJ, Eclipse, or Visual Studio, both Visual Studio and Visual Studio Code, and see that actually, if I'd used this, I would have already seen a policy readout right here in my IDE saying this struts2 core contains a critical issue. But this doesn't only alert me to issues, it can also help me find out better versions or better ways of dealing with this component. Perhaps the best way of doing this is to just find a way to select a better component, such as a later version here. This release histogram allows me to see at a glance which versions of this component do not violate this policy. I can see that there's a newer base version for my application, 2.5.20, which means that I can actually view the details of this component over here, see that that wouldn't violate any of our policies. So perhaps the easiest way for me to fix this is just to upgrade my software over here. Once I do that, it automatically refreshes my bill of materials, and I can see I no longer have any policy violations. So let's go ahead and commit that change. And let's run that build again.
Okay, 3 minutes.
Fantastic. Now, as we run the build, we can see that it should complete normally and give us a green bill of materials. As you can see, this sort of activity can be incredibly tough to spot unless you have the tools to help you spot the traces of your entire software supply chain. Keeping track of everything that goes into your software can be incredibly tough. But you, the viewer, might be thinking, this was a little bit of a contrived example. I've just indeed gone for a deliberately selected application. But what you might actually want to notice is none of the activities that we've done in this example has been deliberately contrived. We've simply used template containers, template applications, and just built them into our system. Having this, we can see that the container now has been fixed, and if we just quickly try running a similar thing, we would see that this vulnerability is no longer accessible, and our bill of materials is now green. That's the power of having software supply chain automation, is to be able to prevent these sort of vulnerabilities happening. There was actually two things that happened here. Not only did we have a deliberately vulnerable application that was over there, also the container that we chose to base this image out of contained our vulnerabilities. So one sin led to another, which led to another, which led to our container to be vulnerable to this particular application. Now, this is more common than you think, and it does happen all along. So as a developer, it's important that I have all the tools available for me. And that's what the Nexus platform can do, all the way from being able to audit the components that you're selecting in the beginning of your cycle by going into your component repositories, all the way from running scans and being able to ensure that your software supply chain is clean. So do try this at home. Do give it a go. Give us some feedback. You send us some pull requests, and hopefully you'll have some fun playing around with software supply chain vulnerabilities.